in our phospholipid in our SN or C3 position, we have our phosphate group, right? And then we have attached choline to it. So this is phosphatidylcholine right here. Here are our two lipids attached, right, our esterification of our lipids to our glycerol backbone. And here's this extra one. So when we look at the polarity, right, so we have this phosphate group, which gives it a relative polar head. And then here we have our fatty acid, esterified fatty acid, so our lipid tails, right? So you can swing the phosphate group up and the lipid groups down. Over here, relatively speaking, except for this positively charged nitrogen, we're looking at more of a non-polar situation, right? Where you've got choline attached to that phosphate group, which, given the fact that you have all sorts of things floating around, allows it to be a little bit ambivalent, like both. It can interact polar and it can interact non-polar. Don't mistake this phosphate group for being neutralized. That's important, and that gives it its ability to interact with water, right, so that it can be the polar head group. But when you have this extra thing over here, you have a little bit of a characteristic whereby you're not just totally attracted to water and totally repelled by something else. That's what makes it useful as a phospholipid, because it can still interact with the other parts. Does that make sense? Okay. All right, move back here. And I won't ask you to draw that or recognize it, but when I'm talking about phosphatidylcholine, it's choline attached to the phosphate group on the SN3 position of your triacylglycerol. So we obviously